on this image. And most of you probably saw a few of those. And there's an interesting thing that you can see here. So I've highlighted 5 objects on the same image. And when I took this object, none of those 5 objects were known. I was the first one to ever see these. Now, one of those is not like the other. You've heard that song, right? It's a short segment. Because we know about planetary motion around the sun, we know for images taken like this, and this is the same trick that Clyde Tombaugh used in discovering Pluto and why he knew he found something very interesting, is if it's moving just a little bit in that time, we know it's a long way away. So these 4 long trails are main belt asteroids. And I've discovered probably about 40 or 50,000 of these things. I've stopped counting. They're just so easy to find in comparison. The little short one, that's a Kuiper belt object. And I've to date found about 2,000 of these. And I like those much better. But you'll notice there's one thing about this image, that it's mostly empty sky, and then there's a few stars here and there. But when we got time to work on finding a target for New Horizons, there weren't any. Why? Because it's in parts of the sky that are just full of stars. So we had to go to really big telescopes. Here's one from Hawaii, the Subaru telescope that the Japanese have built. It's a wonderful facility. Another one in Chile, built by Carnegie, called the Magellan telescope. And we took pictures that look like this. Okay, now this is a tiny fraction of one of these images, much smaller piece than the image I showed you before. And our job was to find the faintest object we'd ever found in fields that look like this. And you say, okay, what are we going to do now? There is actually a main belt asteroid in here. And what we did was to take the first image, and in the computer you subtract the 2. And you have to adjust because the images are not quite as sharp in the second image. And this technique was invented by Allard and Lupton about 15 years ago, and we applied it to these data. So you take the difference, you get rid of all the stars, and you leave behind the moving objects. Well, I spent 10 years looking for an object for New Horizons to go to using those telescopes with images just like this. And we finished an initial processing of the data, and I found about 20 objects, and we thought we should have found about 80. And I said, oh no, what is wrong with my software, my techniques? Something is horribly wrong. I'm not finding enough objects. We're never going to find a target for New Horizons. And so I dug in and worked on the code, made it better and better and better and better. I'm glad I did, because all the tools that I used for that have been immensely powerful and useful for all the Ultima Thule data that we're taking now when we have to subtract out that complicated star background. So I even reached out to the Ice Hunters, which was a group that we created on Galaxy Zoo, which was a citizen science project to get people like you to help out finding things. We didn't find anything else. And we went back to the telescope, tried it a little bit harder, improved our techniques, spent years, a few more years taking data, looking for an object, and we found the best we could find was something that would take about twice as much fuel as we had on board. And in space flight, close is just not good enough. You got to be able to do it or you can't do it. At that point, this was early in 2014, and we had to go to the Hubble Space Telescope. This was our last-ditch effort. Hubble has got much better spatial resolution. It can see finer detail in the sky. It can see in between all of the stars. And also, very importantly, there's no atmosphere to get in the way, and it doesn't make the images change from one time to the next. So here's an image with the Hubble Space Telescope of an area just like the area that I showed you before from the ground-based images. And you can see there's a lot of dark stuff in between. But wow, isn't this a really crazy complicated image. There's all sorts of specks of light on here. Most of these are stars, but there's also lots of other things like electrons that slam into the detector and create a little bright spot. And that changes on every image, and you have to look past those. I'll give you a hint. There's MU69, Ultima Thule, is actually on this image. And I bet you can't find it unless you know that there's a green box circling it. And I'll let you see if you find it. Okay, so how do we do this? So first of all, we've got the best telescope ever made. I used to work at Space Telescope Science Institute at the time it launched and helped teach it how to do planetary observations. And it has been a workhorse tool of me for my entire career. So what we do is we take pictures, okay? Each orbit of Hubble takes 90 minutes to go around. During that time, you get 45 minutes to look at your patch of sky. During that time, I take 5 exposures, okay? And the object's moving the whole time. And then we wait till the next orbit, and we take another 5 images. With New Horizons, we know exactly how fast an object needs to be moving in order for it to be on an orbit that New Horizons can get to. And we say, this is where New Horizons will be on January 1st, 2019, and then we run an orbit for the kind of object we're looking for backwards in time to say where we're looking for. So then we know exactly how fast it's moving. So here, I'm showing, this is actually the discovery image of MU69, and I'm going to walk you through this because I think it's kind of cool. So on the bottom, you have 2 rows of 5 images. The ones in green is the first orbit, one picture after another, and these took about 7.5 minutes to collect. And on the bottom, in orange, that's the second set of 5. Now, if I have a real object, and it's at a velocity that's interesting to us, it will be in the same place in these 10 images on all 10 images. And if you stack those 5 images up and average them out and say, I'm only going to keep pixels that are always the same brightness, in other words, if there's a bright spot on one image and there's not a bright spot on the other, well, I'm going to say that's not a real thing. And on the top, on the left, outlined in green, is when you add up all 5 of those images. And you see that there's a nice bright white spot there. That's MU69. That's the object we're looking for. On the right-hand side is a stack of those same images. Now, I have drawn a red circle there. I did not draw a red circle about the white dot. I draw the red circle where the white dot must be. And if you look at this image, and I had to look at thousands upon thousands of these images where I'd have a white dot on the left, and there would be a white dot somewhere else in the orange one. And after a couple of weeks working on that, I was wondering if my software is broken again, and am I never finding it. And the instant this image hit my screen and I saw 2 white dots in the middle of the red circles, I got a chill that said, we have an object, and I knew immediately that all our calculations were right. We were going to have an extended mission. And that was a really fun meeting on our daily status report coming back. And I just written up the name of this object. And this object has had a few names here. I've listed them all here. Its very first name was 1110113Y. Okay, this is base 36 counting. Work it out sometime to say how many objects I had to look through here. It was tens of millions. Okay, but that was the numbering scheme I worked out. And that would tell me exactly where to find the data and how to find the object. And I wrote down this license plate on my chalkboard for our daily meeting. And I didn't say anything other than say, I might have something to show you today. And they walk in and they see that number. And then we're off to the races. So we got to do the rest of the survey. We found 4 more objects. But on that day, when I just found this object and we had that meeting, I told Alan, this is the one we're going to. Not the second, not the third, not the fourth. It's the first one. And he said, why is that? I said, that's exactly what you would do if it's a Hollywood script. So that's got to be what's happening. So he made us look at all the others and look at it. So PT1 stands for potential target 1. And we had potential targets 2, 3, 4, and 5. And 3 was the other one we could kind of get close to. And we thought you guys couldn't handle listening to press releases for years of 1110113Y, so we renamed it to PT1. But then once it's discovered and it's known as a real object, then the Minor Planet Center gives it a designation, which is the 2014 MU69. And then after we get a really good orbit, then it gets another number, 486958. And then we have the informal name Ultima Thule that we're using, and sometime after we finish this encounter, we're going to give it a lasting final name. Just one little factoid to leave you with. This discovery image, the first green image on the left, has 144 detected photons in it. It's an incredibly faint object. And to see it looming in our field of view with the spacecraft images that we're taking right now is an immense relief to me. You have to, is this thing really real? It is really faint. And sometimes when we go to take pictures of it with the Hubble Space Telescope for monitoring and doing the orbit refinement, it's not there. What happened? We don't know. It's back to this big light curve mystery that we've been fighting with for several years. And I'm really looking forward to finding out what the answer in the back of the book is. And so this is what it looks like moving around relative to the stars. But it's been a great voyage, and I just am so thrilled to be part of the Discoverers Club and call Clyde Tombaugh one of my predecessors and find the next object for New Horizons mission. So thank you very much.
Thank you, Dr. Bowie, and thank you for that discovery. Discovering a flyby target was the first step. Next, we had to map out a plan for learning about this mysterious object. Here to discuss this scientific wish list are New Horizons project scientist Dr. Hal Weaver from APL, Deputy Project Scientist Dr. Kathy Olkin and Dr. John Spencer, both from Southwest Research Institute, and science team member Dr. Sylvia Protopapa, also from Southwest Research Institute. Hal?
Okay, thank you, Adrian. Yeah, let's talk about, first of all, what makes Ultima Thule special. Where did it come from? Where is it? And you've heard this a number of times now. Ultima Thule is in this third zone of the solar system that we've only known about since the early 1990s. It's out at the outskirts of our solar system. But it's actually, there's several different kinds of families of objects in the Kuiper Belt. And Ultima Thule is unlike any of the other Kuiper Belt objects that we've explored so far. We've already flown by Pluto. That was one type of Kuiper Belt object. Cometary nuclei that get pulled into the inner solar system originally came from the Kuiper Belt. That's the second family of Kuiper Belt objects. But Ultima Thule, unlike those others, which probably formed much closer to the sun and they were pushed out, Ultima Thule has always been at nearly the same distance from the sun for the last 4.6 billion years, nearly a perfect circle in its orbit around the sun, in the same plane as the giant planets in the solar system. And for that reason, we think that it's the most primitive object ever explored by a spacecraft. And we have no clue as to what it is going to tell us. But the other interesting thing is, what you're seeing in front of you is a diagram of our solar system. It shows you the architecture of the solar system. But we aren't unique. Our solar system is not unique. And that's the other neat thing that we've discovered over the past couple of decades, that the process by which planetary systems formed are common throughout the galaxy and indeed throughout the universe. Almost every star, when it forms, starts from a slightly rotating, almost spherical cloud of dust and gas. Within the center of that, the star forms, and the disk, because of the rotation, starts to collapse down into a very, the cloud starts to collapse down into a very thin disk, like the middle picture at the top there. And then within that, condensations form. Those are planets forming that then eat up all the material in their orbits, forming gaps. And then finally, to the far right, you get a mature planetary system like our solar system. And the neat thing about astronomy is that actually you have a chance to look at all kinds of different stages of planetary system formation by looking at different objects. And down at the bottom, we have several examples where we see early, planetary systems early in the formation. Instead of 4.6 billion years, we're talking about tens of millions of years in those bottom panels. And you see these disks, you see these gaps that indicate that this process is very common. And that's one of the neat things about the New Horizons mission. We're out there exploring the architecture of solar system formation and planetary system formation. And with that, I'll hand it over to Kathy.
Thank you, Hal. So I just want to tell you a little bit about our science objectives. And there's many things that we can see with the spacecraft that there's no way to tell from our ground-based and orbiting telescopes. And that's things like what the geology and the shape of Ultima looks like. We're really interested in understanding the craters on Ultima. This is a way of looking at the other Kuiper Belt objects out there and understanding things that have impacted Ultima in the past. So it's a way of looking at objects that we can't see with our telescopes because they're too small and too faint, and understanding the evolution of the solar system. We're also interested in understanding the color and the composition. What is the surface made out of? What is the nature of Ultima? And we don't have any answers today, but we're going to learn so much as we fly by. Having a spacecraft in the outer solar system, having the opportunity to see this type of object for the first time ever is historic. And when we look at Ultima, we're not sure what it's going to look like. We don't know whether it's one object or two, or whether it is what we call a contact binary, so it's two objects kind of stuck together, or if it's potato-shaped or lumpy. As you heard earlier today, we don't believe it's round. So we're starting to see these clues in the data, in the imagery that we're getting down, but we still have outstanding questions, and luckily, I'm looking forward to answering some of these in this week. From here, I'm going to hand it to John.
So we're taking a tremendous variety of data over the next few hours. Some of it should be already in the bag on the spacecraft. And the best images that we are sure that we're going to get are going to show details as small as about 400 feet on the surface of Ultima. And we will have about 200 pixels across the disk of the object, or whatever the shape it turns out to be. But we're also going for higher resolution imaging, and if our targeting is just perfect, we might get images with 4 times that resolution, showing details down to about 100 feet. These will be not quite as well exposed. They'll be a little bit smeared because of the low light levels, but we're hoping those are successful. This inset here is showing a view of the Martian moon Phobos, with showing the kind of detail, the level of detail that we'll see. And I deliberately cut it off on the top to indicate that we might not be perfectly centered on those images. We're hoping to get it nicely in the frame, but the demanding on that targeting is so extreme that we're not sure we'll be able to get it perfectly centered. So we'll see what happens in the next few hours and days. We'll get color images showing details down to about 650 feet across. Infrared maps of showing the surface composition with pixels that are about a mile square, but we'll get the composition at 200 measurements at 200 wavelengths in each of those pixels to show us what that part of the surface is made of. We'll map the surface that way. We'll be watching it rotate as we approach and depart, so we can look at all sides of it on the approach. We've been measuring the temperatures on the day and the night sides using our big main antenna as a receiver of microwave radiation, heat radiation from the surface of Ultima. Where even right now, there is a massive pulse of radio energy that was sent up a couple of hours ago from the Goldstone antenna in California and the Canberra antenna in Australia, being sent up to the spacecraft. It's probably, I know, past the orbit of Uranus or something right now. That's going to hit Ultima just after we fly past, and we'll be looking for the echo of that bouncing off the surface, being caught with our dish. We don't know if that's going to work, but we're giving it a shot. We're going to be looking for gas coming off the surface, in a cometary kind of activity, something, again, we don't expect to be there, but it's our only chance, so we're going to look for everything we possibly can, and we'll be looking for any evidence of gas or dust coming off it. And we'll be looking for rings and moons as well. This is just some idea of the detail we'll get compared to Pluto. If that highest resolution image is well targeted, which we have, we're getting more confidence of that as we get more information from the navigation team. So the best images that we took at Pluto, if we'd been looking at Manhattan, New York, instead of Pluto, would have shown the kind of detail we're seeing on the left panel there, that we're seeing features down to about 90 yards across. The images we're going to get from Ultima, because we're flying closer, if these highest resolution images are successful, are going to be more than twice as detailed as that, in the showing features down to about 40 yards across. And so we're really looking forward to seeing if those highest resolution images work. And of course, we can't wait to see what they contain. And now I'll hand it over to Sylvia.
Thank you. So Ultima Thule falls in an intermediate size category between comet nuclei and dwarf planets. And it plays, as we have seen throughout the day, an important role to understand the planet accretion. Our current understanding of the Kuiper Belt is that of an extremely diverse population of dwarfs. The largest are dwarf planets like Pluto, with active geologies, atmospheres, surfaces covered by organic materials, water ice, and exotic ices like methane, nitrogen, and carbon monoxide. These exotic ices are often called volatiles because even a slight warming will cause them to evaporate. On the smaller end, we have primitive, volatile poor planetesimals, what we know of as the building blocks of the planet. Objects as large as Pluto and as bright as Pluto are relatively easy to observe with telescopes on Earth. Ultima Thule is much smaller. It has a diameter between 15 and 20 miles, while Pluto has a diameter on the order of 1,500 miles. Therefore, accurate measurements with any Earth-based telescope are impossible. The New Horizons flyby of Ultima Thule will provide our first ever measurement of the composition of a Kuiper Belt object this small. This is an unprecedented opportunity that provides us the possibility to go back in time and determine which ices and minerals were incorporated into the building blocks of planets. Additionally, observations of Ultima Thule will enable us to understand the degree of diversity of the Kuiper Belt, which in turn serves as a tracer of the physical and chemical processes at play during the formation and evolution of these objects. In the past few decades, missions such as Deep Impact or Rosetta have provided us a very detailed portrait of short-period comets, which are thought to have escaped from the Kuiper Belt. Here, as an example, we have comet Hartley 2, as seen by the Deep Impact Extended Investigation. Several processes may have affected comets during their long storage or during their many passages close to the sun, and their surfaces may have no longer be representative of their primordial origin. Comparing and contrasting the physical properties of Ultima Thule with those of comets will help us determine which features of comets are truly primitive and which instead have emerged because of their history in the inner solar system. To me, the most interesting materials to look for and characterize on the surface of Ultima Thule are organics, water ice, ammonia, and carbon dioxide, and determine whether any of them resemble those detected on the surfaces of comets. To conclude, New Horizons will unveil a critical but yet missing piece of the complex puzzle of planet formation and evolution. Thank you.
And thanks to our panel. And now let's check in on the progress of New Horizons using NASA's Eyes on the Solar System as the spacecraft approaches Ultima Thule.
The round-trip radio communications time between Earth and Ultima is over 12 hours. When was this closest approach sequence uploaded to the spacecraft, John, and what activities are currently taking place on board?
We uploaded the sequence over a week ago, but we left some flexibility, so if we made discoveries after that time, we had one observation that we could point at any new objects that we'd want to look off from our main target to look at. So those observations are being taken right now. It turned out we didn't find anything that required that change, so we're still looking at Ultima. We're taking some more high-resolution images as we begin our closest approach.
Thanks, John. And this is New Horizons Now.
As we speak, New Horizons is heading into the busiest stretch of the Ultima flyby, its science instruments zeroed in and covering this mysterious Kuiper Belt object. You just heard what we want to learn about Ultima, but how are we going to learn it? Here is the answer that will be brought to you by our New Horizons co-investigator, Kelsey Singer of the Southwest Research Institute, and Kirby Runyon, a science team postdoc from the Johns Hopkins Applied Physics Lab.
Great. Thank you, Adrian. Hi, I'm Kelsey.
And I'm Kirby.
And we're going to tell you about the 7 amazing instruments on New Horizons. And these instruments also have names. I will give a shout out to anyone who has a similar name to an instrument on New Horizons. We have Lori. Doesn't have to be spelled the same. We have Ralph. We have Alice. We have Rex. I would be really surprised if there's anyone named Swap or Pepsi, but shout out to you if you are.
And if you have the initials SDC, that counts too.
Yep, I agree. So we're going to tell you about the science that these instruments do, starting with Lori.
Yeah, thanks, Kelsey. So Lori is the long-range reconnaissance imager on board the spacecraft. And it's basically has 2 main functions. We can see distant things, we can see distant things for one thing. Or if we're already kind of close to those things, like we were back at the Pluto and Charon system, we can see close things really close up. It's a fantastic telescope connected to a high-resolution camera. And the way it does that is by having a really small field of view. If you held up a drinking straw, that would be about 1 degree. Well, the field of view for Lori is less than that. It's 0.29 degrees looking through it. So it's a really small, narrow field of view, which allows you to really zoom in on things really far away. And when we were at the Pluto system, we could see Pluto's beautiful moon Charon really up close as this big, round world. But we could also see the slightly more distant small moons, Styx, Nix, Kerberos, and Hydra, as more than just little pixels or points of light.
All right, on to our Ralph instrument, which is actually made up of 2 different instruments. So again, shout out if your name is MVic. Or Lisa, and I actually know someone who spells their name this way, so. But I'll tell you about what these instruments do. And MVic is our color camera. And you can see an example here of what MVic did at Pluto and Charon. These are enhanced color images, but it really helps us pull out the different compositional units across the body. And we're going to do the same thing at Ultima Thule. And MVic looks in visible wavelengths that you can see here, showing the spectrum of different wavelengths of light. But it also builds up a picture by scanning. So this short animation is going to show you how MVic has a very narrow field of view. It's actually very narrow, but 6 straws across. And it uses that to scan and build up a picture of any length. LISA looks in 256 different visible wavelengths. Infrared wavelengths, moving into the infrared now. And it looks in all these different wavelengths so it can build up a signature of the composition. And this animation is showing you looking at a simulated central object and maybe a moon off to the side. And it's going through these different wavelengths, building up a picture. And you could see that there was a difference in the signature, which meant there was a difference in the composition of those two objects. So now moving to the ultraviolet, on the other side of the visible, we have the ALICE imager. And ALICE's main job is to look at the atmosphere mainly we looked at Pluto's atmosphere. But when we get to Ultima Thule, we're going to search for any coma or gas around it, as was talked about in the previous panel. And so this instrument will be seeing if we see anything that looks like a comet coma around Ultima.
That's right. And moving on to the other instruments, there's two instruments that look at the environment that we can't see with our eyes or even anywhere in the electromagnetic spectrum. And these are two of our plasma instruments called SWAP and Pepsi. So shout out if your name's SWAP and Pepsi. So SWAP is the solar wind around Pluto, but it works at Ultima also. And there's also Pepsi, the Pluto Energetic Particle Spectrometer Science Investigation. Now, we have these ionized particles, these particles that have their electrons stripped off of them. And Pepsi can determine the mass and the energy of those particles, and SWAP can determine the density and the speed of those particles. And they're located around the side of the spacecraft. And back at Pluto, we wanted to answer the question, what is the relationship between Pluto's atmosphere and the solar wind, this constant stream of charged particles coming off the sun and flowing out past the planets and really hitting up against interstellar space. This, of course, is a beautiful view, experiencing a Plutonian solar eclipse, where we see that beautiful blue haze of Pluto's atmosphere. And what happens as Pluto's very weak gravity can't quite hold on to all the atoms and molecules in its atmosphere, some of these methane atoms can actually start to escape the planet's weak gravity. And then ultraviolet light, the same thing that will give you a sunburn, streaming off from the sun, shown here in these squiggly lines, interacts with those methane atoms and kicks off some electrons, turning them into ions or plasma. Then protons, which are also positively charged, streaming out from the sun, can kind of interact with those. You know static cling, when your socks come out of the laundry, they stick together? This is kind of the opposite of that, where they repel each other. So these protons have static cling, and they kind of can push aside these methane ions. And in so doing, the solar wind can slow down and kind of pile up like the wake in front of a ship, called a bow shock, seen here as this arc in front of the planet. Now, we're actually not sure if we're going to detect any gases coming off of Ultima, like we had coming off of Pluto, but we've got SWAP and Pepsi operating just to make sure that if there is something coming off, we'll be able to see it.
Thanks, Kirby. Now on to REX, which actually stands for Radio Science Experiment. And that's the dish that you see on the spacecraft there. And REX can be used for both communication and science, and we heard a little bit about that from John Spencer in the previous panel. So we use REX both to talk to the spacecraft and for the spacecraft to send information and data back to us. But REX can also measure radio wavelengths coming off of a planet. And we do that to try and measure temperature of the unilluminated part of the planet. And we did this for Pluto, and we're going to try this again at Ultima Thule. But interestingly, REX can receive a signal both straight from a dish on Earth, a radio signal sent out, or it can receive a signal that's bounced off of a body. And that's what John Spencer had been referring to earlier, and that's what's shown here. And we use that to try and get at some of the materials of the surface properties of the body and the materials that are there. We can actually learn about those materials from this signal that's bounced from Earth off of the object, and then the spacecraft receives that signal.
You have to kind of consider, Kelsey, one thing that I'm really intrigued about is the dance that has to happen, the choreography. At 6:30 this evening, the Goldstone radio dish, part of NASA's Deep Space Network, sent that radio signal out to Ultima. That dish is probably off doing something else now. I'm not quite sure what it's doing right now, but that packet of radio energy, that light traveling at the speed of light, is somewhere in the outer solar system, Uranus, Neptune area, and it's about to pass Ultima, and New Horizons is then going to turn its dish to pick up the reflected signal from that. Just the choreography and the time for all this to happen, it really blows me away.
It is. It's pretty amazing.
It's pretty cool. Finally, we're going to talk about the last instrument, certainly not last but not least on the spacecraft, the Student Dust Counter, SDC. This picture you see in the middle here shows what's called the zodiacal cloud. And this is dust kicked off from asteroids and comets in the inner solar system. And sometimes you can see it before sunrise or after sunset on Earth. It's very faint. But that's dust that can be detected by the Student Dust Counter. And this has been operating through much of the mission, so we can get a profile of how much dust there is as we move away from Earth. And in the parts of the solar system around where Ultima is, we think, or actually this is back at Pluto, we measured 1 dust grain, 1 to 5 dust grains per cubic kilometer. So imagine a few city blocks there. Imagine an empty area of space with only 1 mote of dust in it. That's how sparse it is out there, but yet there's that much dust you can see before sunrise there. So that's the science payload of New Horizons.
Thank you.
Thank you. New Horizons is the amazing story of how teams of talented people, through creativity, persistence, and hard work, can do great things. Following on the documentaries Passport to Pluto and The Year of Pluto, Summoning the Solar System is the next chapter in this remarkable adventure. Award-winning producer Jeff Haynes-Styles is here to preview this inside look at the team conducting the farthest exploration of worlds in history.
Thanks, Adrian. Well, first of all, I'd like to thank all of you for staying up so close to midnight to see these video clips. I think this is a really interesting gesture of belief in video, so thanks for that. I've been to some pretty cold places, the South Pole, but nothing as cold as Pluto, of course. But Life in Science Television, I'm probably one of the only people up here this evening that doesn't have a PhD, so I'm very flattered to be here and sharing their story. Our job is to share the story, and so the videos that you'll see, and hopefully see tomorrow as well, tell the story and pick up many of the themes that folks have talked about this evening. Where do you look at these? Well, hopefully you'll be so excited by the countdown and the close approach that you'll binge watch the 2 hours and 20 minutes of the programs before you come back to find out the results. So you can find them on the New Horizons website, on their YouTube channel, and the 1-hour documentary that we set out to make just sort of grew, and we sort of said to ourselves, an epic mission deserves some epic videos, and excused letting things grow longer. Anyway, somebody who you've heard mentioned several times tonight was the reason, as a historian, I'm now doing science documentaries. I had the pleasure of working with Carl Sagan on the original Cosmos series way back when, and this is us in Death Valley with one of the Viking lander test models. It's actually in the Smithsonian. You can see some of the rain that fell in Death Valley on the color thing. So next time you're in the Smithsonian, when it's open, go and look at the Viking lander. Sagan said things like, dreams are maps. And I think the dream of the Pluto Underground with Alan Stern and many of the other folks are the map that led New Horizons there. And it's great that so many people, David Grinspoon, Jim Bell, who you saw in the Psyche video, were inspired by Sagan, and certainly I was myself. He was a very unique scientist because he believed that poetry, music, were all part of sharing the story, and that's what we've tried to do with these videos. So, we're going to say that I've been an embedded journalist with the team, fortunately, since 2004. That's the best I could do in blowing me up. But I'm in the back there. I still have the same jacket. My hair's changed color. But just like David spent, the various folks that you've seen grow up on camera in the videos, I've changed over the years. Anyway, this is how we start the first program of the 2. The first one is called Part 1, Pluto Explored. And this is the tease. Oh, this is me filming Alice. We film Alice all the time. She's great. So this is the beginning of the Part 1.
Winter 2018. It's cold out here in the distant reaches of the solar system, close to 4 billion miles from Earth. and NASA's New Horizons robotic spacecraft is alone. But it's intimately connected to a team of human scientists and engineers back on Earth. It's their passion, skill, and commitment that powers the mission, just as much as its plutonium fuel. Using approach imagery, they're making final TCMs, trajectory correction maneuvers, to take it as close as 2,200 miles to its next target. After a journey of almost 13 years, New Horizons is closing in for a January 1st, 2019 flyby of a tiny world. It's officially known as 2014 MU69. Now, this icy Kuiper Belt object is being informally called Ultima Thule, honoring the mythical land beyond the edges of the known world. And Ultima is the most distant and most ancient object ever encountered by any space mission. Those long years in flight have seen the awesome success of the 2015 encounter with the Pluto system.
We knew it was going to be scientifically rewarding. We had no idea it was going to be so beautiful.
But just 10 days before closest approach, New Horizons had its own Apollo 13 moment, when the mission ops team had to diagnose and correct a computer malfunction under the most extreme time pressures.
My heart did another flip. I thought, oh my gosh, I really hope it's not that.
That was almost a worst-case scenario.
Exploring the outer solar system is an endeavor in which the United States has led the world. But targeting the close flyby of Ultima has relied on support from nations and space agencies across the globe. It's taken the Hubble Space Telescope and the European Space Agency's Gaia satellite, powerful telescopes in Hawaii and Chile, volunteers and local governments in South Africa, Senegal, and Argentina, and an ambitious night flight aboard NASA's SOFIA flying observatory, deploying out of New Zealand.
The spacecraft has the capability of continuing working for several decades. January 1st of 2019 is just the beginning of another era of discovery for New Horizons.
Out here, in the eternal deep freeze at the edge of the solar system, are clues to how Earth and all the planets began and evolved.
This is even more challenging with Ultima Thule because it's another billion miles further out, it's considerably smaller, it's a very, very faint object.
Climbing Earth's tallest peaks requires the ultimate in passion and perseverance, technical skills, and the age-old longing to explore and achieve. Now, approaching Ultima Thule, this is the human story behind one of NASA's most ambitious missions, summiting the solar system.
Morning. I think I actually have a few more clips, but maybe not. What Hal was talking about in the summer of 2015 is going to be happening again with Ultima Thule tomorrow. And thanks to some of the mission scientists and researchers who took photographs behind the scenes, we can show you what it was like to be in the rooms when the first data came down from Pluto. So imagine that the same excitement, the same joy, the same exhilaration, the same puzzlement and head scratching is what is going to be happening tomorrow and in the future. This is what it was like in the summer of 2015.
July 14th was finally over, but a new phase of the mission was just beginning.
For us, July 14th was when all the action happened and it was a time to celebrate. But then July 15th was when the real excitement began because we actually started getting to see what New Horizons observed.
I would say every day we got a new surprise, but every day we got 10 new surprises.
You would have a whole bunch of people gathered around a given computer screen, and you knew something was going on, so of course you glommed onto that and looked, what is this? What's the new data?
And everyone would just stay late, would get in early. We wanted to come in, we wanted to see what new images, what new discoveries had been made overnight or earlier that morning.
All the pictures were different and they were all spectacular.
Pluto is a collection of the world's coolest national parks all put onto one planet.
Weird ices and flows. Yes, there were impact craters, but they had this rim of frost around them. And then we had cracks, and then we had this brown, oily, gunky stuff on the surface.
There's this large glacier on Pluto, and there's a huge canyon on Charon, and that the North Pole of Charon is red. And what does that mean?
All of it told these stories that were either not necessarily what we expected or so far beyond what we expected that, no one would have seen it coming.
Some people are lucky that they discover one thing in their entire career, and that's an amazing thing. I felt like we were discovering one thing a minute.
The moment when one of my colleagues walked into the room carrying his laptop and saying, "There's haze," and flipping it around and seeing that first departure image that we got where we could see the loop of light around the outside. And this was something that none of us really expected. And so I was then the one that walked into the atmospheres room with a laptop to show them the image, and to see them just hit the ceilings with joy and excitement and, worry a little bit about their heart health. That was quite a moment.
The pace of science I've never seen before or since.
We're all human, and we all wanted to, see what was the newest and the latest, and that excitement was just really evident in every room.
Being in the room when we got the first color image down that showed that the two halves of the heart were different colors, and that was our first clue that they were two very different kinds of terrains. Just moment after moment like that.
It was a magical time, and those memories will last a lifetime for me.
Nothing I'd done prepared me for this type of discovery. It's science, but it's also discovery. You don't get that sense when you go through schooling. It's a very unusual thing to be a part of, in the sense of that much discovery in that short a time frame.
It's going to be a hook that takes me off stage, so I'm going to very quickly move on to a short video clip before anybody can drag me away. So while Hal talked for 5 or 10 minutes, we tried to condense down what's alike and what's different between Pluto and Earth into a minute, and this is part of the education and outreach component led by Kerry Beiser that is also part of the New Horizons mission. So this is how are Pluto alike and different in 1 minute and 20 seconds.
Pluto explored. How are Earth and Pluto alike and different? Pluto is very far from Earth, 3 billion miles, and very cold, minus 380 degrees. Earth is almost 6 times larger, but the two planets are alike in many other ways. Both have glaciers made of ice. Here on Earth, that's water ice, H2O. On Pluto, it's frozen nitrogen gas, which still can flow, even at such low temperatures. On Earth, our mountains are made of rock, but Pluto's so cold that water is as hard as rock and holds up mountains as tall as the Rockies. We've got volcanoes here on Earth that erupt red-hot lava. And it sure looks as if there are volcanoes on Pluto, but most likely oozing exotic ices such as carbon monoxide and methane. Both planets have blue skies and atmospheres containing nitrogen. And both have oceans, with Earth, of course, outside. But Pluto's likely deep down inside. Earth and Pluto, very much alike and totally different. That's Earth and Pluto explored.
I should have said that was designed for upper elementary and middle school kids, but there are some folks that might be older that might be interested in that style of... Anyway, we've taken science on the road through something called Pluto-Palooza, and this was the Cosmosphere where we had a great audience. This was in Albuquerque, And as we said in the video, which we did with Craig Worth, which was shot here by the APL video crew, Pluto-Palooza and Pluto and New Horizons are mazes. Please look at the face on the right as Alice explains something about the way in which the spacecraft works. I think that I'm running into my next piece of video, so I can actually, I think, do this because I'd love you to see the ending of the second program, which is talking about the human impact. You heard about the science, but New Horizons is a human adventure, the team of teams that everybody's talked about, and this is why in this second program we talk about this being a new golden age, and we talk about insight. We mentioned Lucy, we mentioned Psyche, and the folks from the mission look back on the human impact of New Horizons.
With almost 2 billion mentions across the web and social media in July 2015, the Pluto Flyby was NASA's most popular event to date. But as mission members shared the scientific results and engineering successes through interviews and public outreach, they began to realize the human impact of New Horizons extended beyond astronomical discoveries.
We have inspired a whole generation of young scientists to go and explore and to think about space, and most important, to do their math homework.
The most powerful story that I can tell is after giving a speech in Florida about 9 months after the flyby. There was a line and a woman was in it who came to me crying. She was literally crying. And she said, I wanted to shake your hand because my son was flunking out of high school until the New Horizons flyby. And he watched it, and he said to me on flyby day, I want to grow up and do that.
You have to see the look on the faces of the kids when you show them these pictures and you talk about Pluto and all the excitement of being involved in seeing this stuff.
And she said, it's his second semester since the flyby, and Mr. F student has become an A student. And I want you to tell the people that work on New Horizons that you turned him around. And wow, as a scientist, to have that kind of an impact on somebody's life, for those of us who worked on this project, to hear personal stories like that, nothing could be better. The fact that we can move people that way with one little robot 3 billion miles away.
From the first push for the mission in 1989 up through the 2019 flyby, it's been a long ascent with hard work and many challenges met and mastered. The summits of the solar system have been achieved, a feat of passion and persistence that will live for the ages.
We've learned so much more already just by having seen Pluto. And that's going to be the gift to the next millennia, is opening up that perspective that was closed to us before going out to see Pluto.
When we talk about the golden age, we're always thinking about the past. We don't think about actually being in a golden age till you are in the future and looking back and realizing all the amazing things that you did, and maybe we're so busy you didn't realize that, or it was just commonplace.
Have we come to the end of exploration of the solar system? No way! There's way more things to explore out there that we've not seen.
Think about this. The New Horizons team explored farther than any humans in history. And the only humans who are going to break that record in the foreseeable future are ourselves with our next flyby in 2019. It's mind-boggling to think that our friends and colleagues did something of that scope. And it's very special to have been a part of that.
10, 20, 30 years from now, just like when we were looking back at the moon landing, people are going to be looking back at now and saying what an amazing time that was. And my hope is that 30 years from now, when they're looking back at this time, they're going to be doing even more amazing stuff.
So, we actually have half an hour's worth of video clips that are designed to be played in here and also out in the dining room area. There are subtitles so that you can chatter and look up at the screen as you wish. That's going to be starting, I think, right now, and also running in here if you care to stay and watch some of the other scenes. There are scenes of the occultation campaigns that Mark Bowie talked about. There are scenes about behind the scenes of the operational readiness tests in fall 2018, looking towards Ultima. So that's something that you can look at until midnight when Brian May will be here. I have to say, between the king of the Kuiper Belt and the guitarist from Queen, I'm surrounded by royalty, and it's amazing. Anyway, thank you very much for coming along. Start the video. Thank you.
Before New Horizons arrived at Pluto, NASA's last first-time visit to a planet had been 26 years earlier, in 1989, when Voyager 2 arrived at Neptune. Many future members of the Pluto mission had been at JPL, watching the images of Neptune and its moon Triton scrolling up line by line. John Spencer had longer hair then, but already always had a camera at hand. With no new missions to the outer planets underway, many wondered what would be next. 2 years later, the U.S. Postal Service issued a set of stamps commemorating America's visits to the innermost 8 planets and honoring the spacecraft that had reached them. But the stamp for Pluto read, "Not yet explored." That rankled planetary astronomers at JPL and added to the ambition of Alan Stern, Mark Bowie, Fran Bagenal, and others who, in 1989, had already dubbed themselves the Pluto Underground and started pushing for a first mission to the last planet. Finally, in early 2015, a spacecraft began approaching Pluto.
In the months and weeks leading up to the Pluto encounter, every day was exciting. Every day brought new information about Pluto and Charon and the small moons. We would have new views of Pluto, unlike something that we had ever seen before. I felt like I was a kid in a candy shop. I would go to work, 7 days a week, be there all hours of the day because there was nowhere else that I wanted to be. That was where the excitement was happening. That was where the new data was coming down. We were seeing something new that we had been waiting more than a decade for. And it was really exciting every single day.
One of my favorite pictures from that first day is a picture of a dozen geologists up against the big display of Pluto, pointing out all these things. Oh, is that this? Is that this? Doing instant science in that first half hour.
While the science room was abuzz, the Mission Operations Center was empty, except for a cleaner. New Horizons was alone in space, running through the pre-programmed commands that had been radioed up a week ago. The spacecraft was busy with some 236 separate scientific observations. All 7 of its instruments were focused on Pluto and its 5 moons. There was no time to turn the antenna back to Earth. Although New Horizons was alone in space, it was, of course, very much on people's minds at APL and those watching NASA TV coverage around the world. Alan led a countdown to the actual moment of closest approach.
6, 5, 4, 3, 2, 1.
Then it was time to cancel that stamp from so many years before.
A long time ago, the United States issued a set of stamps for the exploration of the planets, honoring all of the spacecraft that have been first to each and every planet. And we have a copy here of the stamp that was issued for Pluto because it was the only planet that was not yet explored. This is from 1991. You can buy these stamps, but about 2 minutes ago, we just made it obsolete.
Once the science team had time to study the amazing images that were returned on July 14th and in the months to come, they were astonished to see that Pluto showed many examples of phenomena also seen on Earth. Glaciers, volcanoes, mountains, and even blue skies. Soon they were engaged in looking at what seems similar and, many times, completely different.
Planetary scientists love to compare similar processes on different bodies. It's called comparative planetology. You compare the different experiments that nature has done.
We're all wired for comparative planetology. We can all look at one thing and it'll remind us of something that we've seen before.
We use what we know about the Earth to try to inform our knowledge and understanding of what's going on Pluto.
We see these analogs, but in completely different contexts on the Earth. And yet they behave the same way, but at vastly different conditions and for materials that are vastly different from each other.
On Earth, we have glaciers that are made out of water ice. On Pluto, we have nitrogen ice glaciers. How do they differ? How are they similar?
The single biggest feature on Pluto's surface is a region that we call Sputnik Planitia, which is this giant sheet of nitrogen ice, frozen nitrogen ice.
This vast plain, smooth plain, had no craters whatsoever. It was gigantic. It's the size of Texas and Oklahoma combined.
It almost fills one hemisphere of Pluto and produces the left ventricle of that heart of Pluto.
We had no idea what we were looking at first. It took us a while to even develop some hypotheses of what this could possibly be.
Sputnik Planitia, I like to say, gives Pluto its mojo. It really is the source of almost everything that we see on Pluto. This giant sheet actually moves like a glacier.
That to me is such a favorite because it's like, wow, that place is like, it's like here. You know, you see things that we see here on the Earth and with materials that are completely different.
It's very much like a water ice glacier on the Earth. It flows, can flow around barriers.
The secret to Pluto's activity is that its surface is full of these very mobile, super cold ices, solid nitrogen, solid methane, solid carbon monoxide, and it doesn't take a lot of energy to make this stuff move.
The bonds that make nitrogen ice crystals are different than in water, so they're actually weaker.
Nitrogen ice is very soft. It has kind of the mechanical properties of a slightly stiffer version of silly putty.
But when you look in detail, you see that there are these giant sort of blisters that are separated by little sort of ridges. And these blisters are maybe 30, 50 kilometers across. They have the pattern of upwelling and downwelling material that's moving slowly like churning oatmeal on a stove.
The surface has all of these polygons on the top, and we think that they're convection cells. So what this is saying to us is that there's a heat difference between the top of that nitrogen ice and the bottom of the nitrogen ice.
The core and the mantle of Pluto have just enough radioactive material in it that slow decay of the radioactive material produces just enough heat to stir these extremely volatile ices, which are mobilized at only a few tens of degrees above absolute zero.
It's sort of like a lava lamp. You get the heating of the material in the lava lamp, these blobs go up, and when they cool, they come back down, and that's similar to what's happening to this nitrogen ice on Pluto. And what that means is that surface is relatively young, geologically speaking. And in fact, we had our highest resolution images cutting across Sputnik Planitia, so if there were craters there, we were going to see them, but we didn't detect any.
As a person, what surprised me the most was how beautiful the landscapes are on Pluto, with twilight hazes and a blue sky and big ravines, gorgeous mountain ranges that have snow caps on them. And although there are craters on the surface, and you can certainly tell it's a faraway world, I don't think there's a more photogenic planet other than our own in the solar system.
So the process for getting these procedures together is we build them, we then review them as a group, we look through the actual code, and then we test them on the simulator before uploading them to the spacecraft.
We actually did run everything through the hardware simulator.
We have a process for commands to go to the spacecraft. It's a rigorous process. Sequences are created, reviewed, tested. Things were accelerated.
Typically this period is 10 weeks long, and we were compressing it into 2 days.
But the careful testing took time, a resource that was in critically short supply.
It was the uplinking of the sequence on board the simulator that took a lot longer than anticipated. And so we made the decision to start loading what was already tested while we were still testing the back end of the sequence.
We were reviewing the script at the same time as we were testing the script, at the same time as we had to run some of the script on the spacecraft.
Nick Pinkine is grabbing the next set of commands hot off the simulator. Literally, the ink wasn't dry when we were handing them to the flight controllers for immediate uplink.
So I would work with the simulation team to figure out how far along in the recovery they had got on the simulator, find a good break point to then go into the flight control team and say, okay, this is what we're ready to do.
The flight control team is the last line of defense of all the mission operations personnel that have to verify that the commands that we're sending to the spacecraft are what we intend, and so that we don't make a mistake that we can't recover from.
So literally the scripts that were running on the screens, like we were keeping track of where did we just finish. We finished at line 147. Okay, now we're going to pick up and do lines 148 through 215.
They were coming at us rapid fire, and as soon as a test was completed, the uplink request form was being written and signed off and run into the mock for us to get those commands up to the spacecraft with no time to chit-chat about it and talk about what we were going to have for lunch.
We always had to make sure we never got ahead of ourselves, where we didn't have a case where we were sending commands to the spacecraft that we hadn't tested already on the ground.
So in some ways we couldn't believe that we were doing this. While the back end was being fed through the simulator, we were taking the front end and plugging it into the spacecraft.
So we were stepping through it in real time to send the commands to the spacecraft before the bottom half of the recovery script had even been completely verified on the simulator. And again, that's not something that we would ever typically do. It's just we were under such a time crunch that we had no choice.
It was a very quick turnaround.
Yeah, at one point we were within 5 minutes of each other. The operations on board the console for the spacecraft were just 5 minutes behind where we were in the testing.
Some people have this idea that flight controllers are sitting there with their game consoles, telling the spacecraft to move this way and take this picture and, all right, do this, do that. And it never really works that way. This case was the closest we've ever gotten to that real-time joysticking of the spacecraft, where we were, as quickly as we could, getting our commands ready and sending them to the spacecraft.
Having to joystick the spacecraft to an extent just made things that much more challenging, with that much more pressure, but our hand was really forced to do that.
We were on the edge.
In an unexpected situation, there are always nerves, but in this case, we knew what was on the line.
For the mission ops team, there was no more day and night, no on or off the clock. It was coffee, cat naps in offices, and chocolate until they got this solved.
I came in expecting to work for an hour and go into the beach, so I was wearing my shorts and my sandals, and I ended up staying for 3 days.
At 8 a.m. on July 7th, we saw that the spacecraft had transitioned into what we call a 3-axis mode. And this is the mode that the spacecraft has to be in to take all those beautiful pictures.
It really wasn't until we saw the actual load up there, active, ready to go, that we could really be relieved.
And then we watched as the onboard sequence transitioned into the encounter sequence at about 12:30 Eastern Time on the 7th, at the exact time that we needed it to do.
Waiting for the final confirmation that we were on the primary sequence again was slightly nerve-wracking, but I think at that point we were all so tired that we just wanted to be done, and we had tested everything and gotten to that point. We were, again, confident that it was going to go the way we expected it to, but it was euphoria to see that it had actually happened. And I think we were all checking our watches or the clock on the wall to say, wow, that was really close. I think we had 4 hours to spare.
While Alice and the mission ops team waited in the mock, Alan Stern and the science team gathered to see whether their 26 years of effort was all for naught. As they saw new data arriving, they shared in the relief and euphoria.
Let's be honest, a 9.5-year mission, you're, 3 or 4 days from entering the encounter phase, where if that would have happened, the ground would have then at that point been completely out of the loop. So just having that much time to respond to a bus controller failure, it's way up there with some of the worst case scenarios that you can still recover from. The ground has just enough time to go in and save the day.
So when we had recovered, there wasn't so much cheering as just okay, let's go get some sleep because we've still got another very long 7 days ahead.
But before sleeping, Alice, Carl, and the team joined in a pre-planned celebration to kick off the week of closest approach. Without the success of their round-the-clock efforts, there'd have been no flyby and no new science from Pluto.
It worked. Everything worked exactly as planned, and we had performed a reverse BCRT swap. We went back on the primary computer. We had reloaded all the memory. We had successfully done our flash burn.
You say a team is the sum of its part, but when you watched it happen, it was much, much more than the sum of the individual parts. We had risen to a higher level than we could individually. It was just simply amazing. People would see what was needed and they would just do it. It was a very memorable experience.
Con Sang and Ann Verbisher had been part of the team in South Africa. Now they were ready to fight the winds and chase MU69's shadow.
Well, we're about to start in 10 minutes, all right. All right, hammer time. Okay, within the next minute. And I will tell you if I see the star disappear. Oh, I saw it!
No way.
I saw it. I'm pretty sure I saw it.
Holy cow.
I actually saw it.
Holy cow.
No, I really did see it.
Several teams thought they'd seen the star wink out. But Amanda Zangari worked all night to verify the telltale signature of an occultation. Finally, at 5:30 a.m., she thought she had enough data to show Mark and the team. All the guide stars aligned. But would the target star blink out?
Okay, we saw it.
Yeah, we saw it too. Did you see it? Did you see it? You saw it, right? That's it. We got it.
We as a team succeeded in getting not one, not two, but 5 different occultations. So we saw the star go out and come back as MU69 passed in front of the occultation star at 5 different locations.
The timing of exactly when the star blinked out and reappeared at the 5 different locations allowed the researchers to infer a shape for MU69. It looked like a possible binary object, 2 chunks of ice and rock orbiting close by or stuck together. Although that might complicate trajectory planning later in 2018, this was an incredibly important result.
It was like finding a needle in a haystack, and to be able to capture those 2 seconds just at the right time, where the sky was clear, where the winds were not more than 7 kilometers per hour, where all those conditions had to be given, you know, it was an incredible orchestration, and I think everything conspired for success. So this was critical data, not only to maximize the science return, but also to mitigate the risk to the spacecraft. It was like the night before Christmas.
I don't care what the weather is today. That's a great feeling. Here it is Tuesday. It's rainy, windy, cloudy, really nasty stuff for astronomy. And it doesn't matter. It's great. It can do whatever it wants as long as I can get out on my airplane back to Buenos Aires tonight. It could snow 10 feet tomorrow for all I care. But we got what we came for.
We are live at the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, counting down to a new year by following NASA's New Horizons spacecraft 4 billion miles from home, just minutes away from flying by the Kuiper Belt object nicknamed Ultima Thule, the farthest planetary flyby in history. Now, Ultima might be the space rock of the hour, but we've got a rock star much closer to home. Brian May, astrophysicist, New Horizons contributing scientist, and lead guitarist for the rock group Queen, tonight will debut a song inspired by New Horizons for this audience and an audience all around the world. Brian, like, New Year's is exciting enough. We get to celebrate it witnessing space history.
This is a night to remember. I'm so privileged to be here and be a part of this. Fantastic. We will never forget this moment.
You know, everybody always asks for the new year. What are you going to do in the year ahead? But we don't have to wait that long. There's some cool stuff happening in the next couple of days.
I can't believe what we're going to see. The thing is, we have no idea what we are going to see, which is what makes it so great, isn't it? So this is completely unknown territory, which is what makes us all so excited at this moment.
Okay, I think we need to get people stirred up. I mean, we've got 20 seconds to the new year. Everybody ready?
We're 20. We're 19.
There we go. Look, just a few more minutes. We'll count down 2018. And boy, do we have something left as we get past that new year. We are at 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Yay!
Happy New Year!
Happy New Year!
Welcome 2019.
Happy New Year, folks. It's a time for kissing and hugging, right?
Absolutely.
To do some...
Okay. So that was the first celebration. Now countdown to the next one. Brian, let's just get to what you've worked on, what inspired by New Horizons.
This is something that I worked on, having been privileged to be a part of this operation for the past few years. This is a song, this is my way of dedicating my respect to this team, which has put together this most incredible journey of all time. This is the farthest, the most distant rendezvous which has ever happened in history. So it's my privilege and my pleasure to introduce to you right now the world premiere of this new theme for New Horizons. Thank you.
T-minus 15 seconds.
Ready. Roger.
15 seconds. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff of NASA's New Horizons spacecraft.
The revelations of New Horizons may help us to understand better how our solar system was formed.
Thanks a lot. I hope it's a worthy tribute.
What an amazing way to start the new year. It was incredible.
Fantastic. I'm very happy.
Well,
thank you for that response. Thank you for that. Thank you for dancing, you know.
I was hoping nobody would see that.
It was you.
We are going to continue our countdown to Ultima Thule. Happy New Year. We're going to come back on the air at about 12:20. In the meantime, we're going to listen to some other things that others have to say about New Horizons. We'll see you soon.
See you in a minute.
Hello, APL. I'm Walter Alvarez at the University of California, Berkeley. As a geologist who studies extraterrestrial impacts on our home planet, I'm just in awe of what you have done with New Horizons, actually going to the most distant planet and now even beyond. With my best wishes for a perfect flyby of 2014 MU69.
David Bren here, science fiction author, congratulating the New Horizons team on approaching Ultima Thule and the well-timed New Year's Day encounter, and adding that this kind of competence that we've seen a dozen times in just 2018 just isn't what we think of ourselves in this time of gloom. It's theologically significant that we're so good at this, at reaching out into the cosmos. And it is important that you other generations overcome the baby boomer anthem of I'm mad as hell and I'm not going to take it anymore. Be proud as heck that you're a member of a species and a civilization, and yes, nations that are doing this kind of stuff. Be proud. Be assertively proud. Grab your neighbors by the collar and say, look what we are doing.
Hello, New Horizons. I want to wish you the best of luck in your encounter with Ultima Thule, the farthest world that humans have ever explored. I can't wait to see what you find.
Hello, Chris Pratt here. As you may know, I'm no stranger to guarding the galaxy. In fact, in my new film, The Lego Movie 2, the second part, you'll see my character Emmett take on aliens of all shapes and sizes. So you know I'm telling the truth when I say I've been to the extremes of outer space. And on New Year's 2019, NASA's New Horizons spacecraft is headed there too, 1 billion miles beyond Pluto, conducting the furthest flyby in history with a flight past the Kuiper Belt object named Ultima Thule. And small worlds like Ultima are the building blocks of the planets, and New Horizons is going to explore one of these icy time capsules for the very first time. How cool is that?
New Horizons, hi, Commander Chris Hadfield here. You are the steely-eyed, high-speed, fleet-footed messenger way out beyond the edge of what we barely understand. Safe travels and happy prospecting as you look at Ultima Thule on the way by, and Happy New Year.
Hi, New Horizons. I just want to wish you a happy flyby of Ultima Thule on this coming new year. We are so excited for your new adventure and cannot wait to see what you're going to bring back for us. Happy 2019.
Greetings, everyone, from the Space Show. Alan, to you and your entire New Horizons team, congratulations for an incredible job, a job very well done with the New Horizons mission. All of you and the spacecraft will enjoy a permanent place in space and human history for what you have accomplished. Way to go. And a very happy new year from all of us here at the Space Show to all of you.
Happy New Year, New Horizons spacecraft. You are about to fly by Ultima Thule, what we used to call 2014 MU69. It's an object way out in the solar system in the Kuiper Belt. We're going to learn more about those objects and about the origin of the solar system and where you and I came from. What a way to start the new year! Way to go, New Horizons! Snap those photos! Woo!
Hey you guys, at the New Horizons mission, I'm Scott Stantis, creator of the comic strip Prickly City and the editorial cartoonist for the Chicago Tribune. Congratulations and good luck on your flyby of Ultima Thule, or, as us old people still like to call it, MU69. Good luck, you guys.
Say, gang, where's that New Horizons spacecraft passing on January 1st?
2014 MU69.
Ultima Thule. Planetary Society can't wait to see those pictures.
Good luck, New Horizons.
Happy New Year from the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland. We have just celebrated our entry into 2019, and NASA's New Horizons spacecraft is just minutes away from entering the history books. At New Horizons flies by a Kuiper Belt object nicknamed Ultima Thule, and at 4.1 billion miles from home, it's the farthest exploration of worlds ever, our first close-up look at one of these ancient building blocks of the planets. Now, right now, New Horizons is not in contact with Earth. It's collecting data at a furious pace, filling its recorders to start sending pictures and other science back to us later today. But with NASA's Eyes on the Solar System program, we can see what New Horizons is supposed to be doing right now. I mean, it's the next best thing to being there, and we'll check on that throughout our program. Now, team members, family, and friends are all gathered here at the Applied Physics Lab to mark this amazing achievement. Now, I mean, just a few minutes ago, I mean, this building was rocking. And the man who led the New Year's countdown and debuted a song dedicated to New Horizons is here with us right now. Brian May, guitarist from Queen, astrophysicist, and New Horizons participating scientist. Brian, this mission has inspired so many people, right? Maybe tell us a little bit about what inspired you to write New Horizons.
It totally inspired me. And getting to know the people who work in all the different departments of this thing. I've been absolutely enchanted by the whole thing. And once I wasn't exactly commissioned to write the song, but Alan and I talked, and he said it would be great if you could do some music for it. And I started to think this mission to me represents more than the mission itself. It actually represents to me the spirit of adventure and discovery and inquiry, which is inherent in the human spirit. So that's kind of what I was trying to build into the song, and I hope it comes across. But it is a tribute to this particular mission and all the people who made it work. It's something incredible, and this is a night none of us are going to forget.
No, and I think the reaction to the song out in the audience indicated, I think, what other people thought of it too.
I hope so. Yeah, I mean, I was nervous, because this is the moment when you present and you think, is this good enough or whatever. But I'm hoping that it will be a kind of catalyst to get the mission out to the public a bit more than it would have done, even so.
Now, you're a participating scientist on the New Horizons mission. And in fact, one of the things I know that you're interested in doing is the stereo imaging. And we've put some of your stereo images already on the project website.
Which makes me very proud. Yeah, I'm happy with that.
Yes, I mean, tell us how you put those together. And I mean, we're going to see more.
Yeah, this is what I put together for the Pluto mission. And I was just very lucky to be there at the right time. These two images look the same, but of course they're slightly different because they're from different angles. And with a stereoscope, I happen to put them on my mobile phone, but this little stereoscope, my OWL stereoscope, turns a mobile phone into a stereoscope, and this is what you see. And you see the thing in relief, you see it in 3D, and it leaps out. And
that's amazing. And I know you put that in books as well. I mean, and the stuff is available online for people to see this in an entirely new way.
Yeah, to me, it's a big thrill, and I'm hoping against hope that we can get these images in the same way for Ultima. How great to see Ultima in one of these things and to experience it close up, because it's like you could touch it in 3D.
Right, and you could say that, I mean, even just the one you did of the dot that was Ultima, that's going to clear anyway. I mean, that's available on pluto.jhuapl.edu. You can find that on there.
Yeah, that's good. Yeah, well, we got two eyes for a reason, really. Evolutionary speaking, we have two eyes because it gives us so much more information on the universe around us. So this is me.
Brian, thank you for joining us this evening and for here on this program. And I can just say, just have fun with your colleagues this week when the data on Ultima starts coming in.
Can't wait. It's been such an honor to be with you guys. Congratulations.
Thank you, Brian. Thank you.
Thank you so much.
All right. From rock legends to movie stars, there are lots of people excited about New Horizons. Now, here's a word from someone who knows about the extremes of space exploration.
Hello, Chris Pratt here. As you may know, I'm no stranger to guarding the galaxy. In fact, in my new film, The Lego Movie 2, the second part, you'll see my character Emmett take on aliens of all shapes and sizes. So you know I'm telling the truth when I say I've been to the extremes of outer space. And on New Year's 2019, NASA's New Horizons spacecraft is headed there too, 1 billion miles beyond Pluto, conducting the furthest flyby in history with a flight past the Kuiper Belt object named Ultima Thule. And small worlds like Ultima are the building blocks of the planets, and New Horizons is going to explore one of these icy time capsules for the very first time. How cool is that?
All right. So, New Horizons is now out beyond Ultima. I mean, it's out beyond Pluto, like 1 billion miles beyond Pluto. But we're still here at APL, and Joanna Wendell is with the crowd counting down to Ultima close approach. So let's go out to the floor with Joanna.
Hey, Mike. Thank you so much. We're here in the Countdown Central, and as you can see, it's a big old party. Everyone's having a great time. We are so excited to be here for this historic flyby. This is the farthest thing that humans have ever explored. We've got people here of all ages. We've got little kids running around in astronaut costumes. I am incredibly inspired by this crowd. So you might not know that much about Ultima Thule, so here are a few fun facts to get you educated. All right, so back on the desk, we're joined by John Spencer. He's the New Horizons Deputy Project Scientist from the Southwest Research Institute. And John, Happy New Year.
Happy New Year to you, Mike.
Now, you led the planning for this encounter, and all the moves that New Horizons is making to reveal Ultima's secrets. We're going to check in on Eyes On to see what's happening with there, but if you could, tell us what the spacecraft is doing right now.
Well, right now, we're making our highest resolution observations of Ultima that we're going to make in the entire flyby because we're just before closest approach. The lighting is perfect to get those really detailed images that are going to show us all the topography and all the details of the surface. We're doing two things simultaneously. We're doing a wide-angle scan with our wide-angle camera that is going to be covering a large swath of space around Ultima. Most of that scan is going to have nothing in it because we're not sure exactly where Ultima is. So it might be over here, it might be over here. And so we're going to just sweep our camera across that whole distance so we'll catch it wherever it is. At the same time, we're using our telephoto camera to take just bang, 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 900 images in a row along the middle of that strip that will be hopefully centered on Ultima. We're really hoping that we're going to get the pointing right on those, but we're not quite sure if it will work or not. So that's our added bonus if we get those highest resolution images. And so hopefully they're happening right now.
I mean, I think that shows the confidence, one, the idea that you really just don't know completely yet, where this is. It's a much smaller object we had to explore before, but the plan, you seem pretty confident, though, that you guys put a good plan together, and now you're just watching it ride through.
Yes, we're optimistic now about how well this is going to go, and now it's just a matter of time to see the data coming down and see what we got. But right now we're taking those most beautiful images that we're going to get, and so it's just going to be amazing waiting to see those.
About how close is it going to come to Ultima Thule?
Closest approach just about now is about 2,000 miles, 3,500 kilometers, much closer than we came to Pluto. Because this is a small world, we want to get as close as we could to it to get the best possible pictures.
Right, and if I look at the countdown clock now, I mean, we're about 3 minutes away, and I'm looking at the distance, and I'm seeing about 2,700 miles. I don't think New Horizons has been closer to anything since launch.
Yeah, that's an amazing thing. It's like half an hour after we left Earth orbit was the last time we were this close to anything.
To be at this point.
And so this is really It's very hard to believe, actually, that this is really happening right now out there 4 billion miles away.
That it's that close. You know, there's like, we ask almost everything about this too, but what do you think? What are you most excited to see?
I think I'm most excited to see the pictures that are being taken right now, because they're going to be the sharpest, show the most detail, have the best lighting to really show us what the Ultima is like. And we're really excited to see those pictures.
Well, I'll tell you what, I'll let you go out to the floor and join your colleagues for the countdown. We're about 2 minutes away. In fact, we'll go out to the floor as well. So let's take it back out to Countdown Central.
Corral the kids. Hey, everybody. We have an American spacecraft 4 billion miles from home approaching Ultima Thule. The spacecraft is currently 2 minutes from its closest approach. It's moving at 9 miles per second. Think about that. In the next 2 minutes, it's going to travel the distance of the entire East Coast from Miami to Maine. If you were on board New Horizons right now, Ultima Thule would be about as big in the sky as a full moon over the Earth. Wow. But only dimly lit, because it's so far from the sun that the spacecraft is bathed in a light that's only the equivalent of a dusky twilight, about the equivalent of 100 full moons. At this very moment, while we're speaking and celebrating this event, New Horizons is taking its riskiest observation. It's trying to get the very highest resolution images as it's zipping by at 32,000 miles per hour. Okay, we're under a minute now, so we're going to start the countdown. 50 seconds to fly by. You guys ready? Are you psyched? Are you jazzed? 45 seconds to fly by. 40 seconds. Join me. 35 seconds. 30 seconds. Just 30 seconds. 25. Shh. 20. We're almost there. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Go New Horizons! Go New Horizons! Woo-hoo! 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 New Horizons is on departure. Go USA! Go NASA! Go New Horizons! All right. Thank you, guys. Thank you, and thank you. They're going to do an interview now up here, a TV interview. Okay. Yeah. Thanks for joining in this. Yeah. Okay. You like that? You like that? Awesome.
Okay. All right, so there was the countdown moment. We are a minute past Ultima Thule. This is space history. No object has been explored up close this far from Earth. I mean, wasn't it enough to think that over 3 years away from Pluto, I mean, it took 9 years after launch to get to Pluto and 3 billion miles. Now another 3 years, billion miles beyond that, we're now past Ultima Thule, outbound from the farthest object yet to be explored. What happens next is the data will start to come back. We'll see tomorrow, 20 months for data from Ultima to ultimately reach Earth, and for the entire package for the science team to begin looking over just this treasure trove of information, of data, in what is literally an archaeological dig into the beginnings of the solar system. These are objects that have been literally untouched, believed to be unaffected since they were formed in this outside region of the solar system. What we're looking to do is go back to Mission Central, the Countdown Central, the excitement there. Joanna Wendell, I believe, is with Principal Investigator Alan Stern. So let's go back out to the floor.
Let's see where. Hey, Alan, so how are you feeling at this second right now?
I'm feeling so proud of our team and so happy for science and for NASA and what we could accomplish.
And what does this mean for space exploration?
Well, we set a record. Never before has a spacecraft explored anything so far away. I mean, think of it. We're 1 billion miles further than Pluto. And now we're going to keep going into the Kuiper Belt. And hopefully we'll have another flyby someday.
How excited are you for the data that's going to be coming down in the next weeks and months?
I can't wait. And this team is raring to go, because for us, this really just starts with the downlink and transmissions that begin tomorrow and will last for 1.5 years.
All right, well, let's get back to celebrating. Back to you, Mike.
Okay, now for all the excitement here, actually in mission operations, it's quiet. Right? Now, the names and messages from more than 30,000 people who registered to be beamed to Ultima have already washed over New Horizons and are heading deeper into the Kuiper Belt. And soon, we'll see if the real Ultima is like anything the small world we've been imagining and the designs that students in the Ultima Art campaign have been sending us over the past few weeks. Now, in about 10 hours, we'll await the signal from New Horizons, the phone home call to APL Mission Operations to let us know if all went as planned. Now, we'll be back on the air at about 10:15 a.m., so join us on NASA TV, nasa.gov, and pluto.jhuapl.edu for this next major mission milestone. Again, Happy New Year, keep exploring with New Horizons, and we'll see you soon.